Good morning, friends. With due respect to the departmental initiative on the creation and development of e-content, in this session, dear friends, will discuss on the improvements in the traditional approach of payback period, that is, the payback reciprocal method, post-payback period method, and discounted payback method for the program Become Subject Financial Management, 5th semester of Vijayanagara Sri Krishnadevara University, Ballari. The second one, the second development in the traditional approach of payback period, that is payback reciprocal method. Payback reciprocal method is employed to estimate the internal rate of return generated by a project. Payback reciprocal can be calculated with a formula: annual cash inflow divided by total investment into 100. The payback period formula is there. You have to just reverse the payback period formula. You will get the payback reciprocal. It can also be calculated in percentage so that we can easily compare the project with other project. This method can be used when these following two conditions are satisfied. That is, equal cash inflows are generated every year. Suppose the project gives different cash inflow for different years, then you cannot go for the payback reciprocal method. Another important condition is the project under consideration should have a long life, at least double of the payback period. The payback period and the life of the asset is almost same, then the payback reciprocal method is not useful. Post payback period means the name itself indicate under this method the profit earned by the project after the payback period is considered, and that is one of the limitation of payback period. Under payback period, we consider only the earnings up to the period of the payback. This method considers the earnings of the project even after the payback period is over. So as per this method, a project which gives maximum post payback profit that can be accepted, or maximum post payback period that can be accepted. This is to be applied where the various projects do not differ significantly as to their size and the earnings or expected earnings or cash inflows throughout the life of the project. This method is also known as surplus life over the payback method. In payback period method, we find out in how many years the initial investment is recovered. And here, under this post payback period, we understand or we compute the number of the years, how many years it will be used or it will be earned after the payback period. Here is an example. Cost of the project is 20,000. It generates cash inflows of rupees 5,000 per year for a period of 5 years. Find out the payback reciprocal. The formula is very simple. Payback reciprocal means the annual cash inflows divided by total investment into 100. So 5,000 is the annual cash inflow divided by total investment is 20,000 into 100. It comes to 25%. Discounted payback method. A very important drawback or the limitation of payback period method is it ignores the time value of money. Time value of money, the value of the money differs from time to time, and that's taking into account or taking into consideration the rate of inflation. In this discounted payback method, an improvement has been done for the traditional methods or traditional method of payback period by considering the time value of money, that is nothing but the discounted payback period. Under this method, the present value of all cash outflows and inflows are computed at an appropriate discount rate. Here the discount rate, you can get it from the table at a 10% rate of discount for the number of the years, and that is the 1 rupee is to be valued at that particular point something. Time period at which the cumulated present value of cash inflows equals to the present value of cash outflows is known as discounted payback period. The time period at which the total cumulated present value of cash inflow that equals the present value of cash outflow is known as discounted payback period method. The project which gives shorter discounted payback period, that should be accepted. That's the recommendation to the management. So here is an example. Calculate the discounted payback period from the following information: cost of the project 6 lakh, life of the project 5 years, annual cash inflows given 2 lakh, cutoff rate is 10%. The present value at a 10% discount rate is 0.909 for the first year, for second year 0.826, 0.751, 0.683, and so on for 5 years respectively. So these discount factors you can get from the annuity table. The present value at a 10% discount rate for the year 1, 2, 3, 4, 5, 6, and so on. So the solution, here you have to make a column. First you have to find whatever information is given, that information you have to write. The first is year. If they give the year, you should write the year, or else you rewrite the number, just 1, 2, 3, 4. Cash inflow, PV factor, and the present value. Next, cumulative present value. The cash inflow, first year, second year, third year, fourth year, fifth year is same, that is 2 lakh. PV factor is given in the question. Or students, I may advise you to just remember this PV factor at 10%. Almost it will be the same. It is to be copied from the table. 0.909, 0.826, 0.751, and so on. The PV factor, the present value. What is the present value? The present value means the cash inflow into PV factor. 2 lakh, it should be multiplied with 0.909. You will get 1,81,800. The cumulative present value means the total present value. First year it is the same amount, that is 1,81,800. Second year 2 lakh cash inflow, PV factor is 0.826. So the present value becomes 1,65,200. That is the cash inflow into PV factor. Third year 2 lakh into 0.751, 1,50,200, 4 lakh. So the cumulative it will become added. 1,81,800 is there first year. The second year the present value becomes 1,65,000. So 1,81,800 plus 1,65,200, that becomes 3,47,000. 3,47,000. Third year you have to add third year 2 lakh, PV factor is 0.751. So you just multiply with 2 lakh rupees, it will become 1,50,200. So cumulative you should go on adding. The second year total should be added with the third year present value, like this up to 5 years. Then you will get the total cumulative present value. The payback period total, the sum of the present value for 3 years is 4,97,200. So you can see the table, but the cost of the project is 6 lakh, and hence the difference is 1,02,800. That is 6 lakh minus 4,97,200. So that should be recovered from fourth year. So we have to find out in how many months of the fourth year we can collect that amount. So 1,02,800, that is the difference amount, divided by the fourth year present value of cash inflow, that becomes 0.75 year, that is 9 months. 0.75 years into 12, that becomes 9 months, and hence the discounted payback period is 3 years and 9 months. So another example we can take over here. From the following information, calculate the net present value of two projects A and B, and suggest which should be accepted, assuming the discount rate 10%. So the particulars given here: cost of the investment is 40,000, and A project, B project is given, scrap value is given, estimated life is given. Estimated life is 5 years for both the project. Scrap value 2,000, 4,000. Cost of the investment is 40,000, 60,000. Here another table is there. There they have given you the net cash inflow and the discount factor. For the 5 years, profit before depreciation and after tax. See, profit before depreciation and after tax, and the discount factors are given. So it is a net cash inflow. For the year 1, 10,000, 40,000, and PV factor almost remains the same. First year is 0.909, second year 0.826. The project A, project B, 20,000, 20,000, 20,000, 10,000, 6,000, 6,000, 4,000, 4,000. Almost same, only 1 year there is a change. 1 or 2 years there will be the change. So we can go through the question. They have given you about the particulars of the project A and B, cost of investment, scrap value, estimated life is given on one table. Another table they have given the annual cash inflows and discount factor for the 5 years. So the project A, we can move to the project A. Solution: years is given, project A. The first year it gives annual cash inflow, that is 10,000. Discount factor is 0.909. So the present value becomes 9,090. Second year it gives cash inflow 20,000. Discount factor is 0.826. The present value becomes 16,520. Third year also it gives net cash inflow 20,000, but the present value is 15,020 because the discount factor is 0.751. As the year goes on, the discount factor reduces. That's the time value of money. Like this you have to do for 6 years. The present value of the cash inflow will be 48,454 for all the 6 years, and the present value of the cash outflow or initial investment is given 40,000. So the net present value is 8,454. Now similarly for the project B, the first year it gives 40,000, second year 20,000, third year 10,000, fourth year 6,000, fifth year 4,000, sixth year 4,000. So you can use the discount factor 0.909. First year the present value becomes, if it is multiplied with 40,000, 40,000 you receive, but the discount factor is 0.909, so 36,360 is the present value. Second year 20,000 you receive, but the discount factor is 0.826, so it becomes 16,520. Similarly, third year 10,000 into 0.751, 7,510. Fourth year 6,000 into 0.683, that is 4,098. Fifth year again 4,000 into 0.621, 2,484. Sixth year 4,000.621, that becomes 2,484. The sixth year is, that is the scrap value. So the total, even the scrap value is to be converted into the present value by considering discount factor. So the present value of cash inflow will become 69,456. So the present value of the cash outflow or initial investment is 60,000. So the net present value becomes 9,456. What you can give a conclusion: project B is accepted as its NPS is higher. The net present value is greater than the project A, so the management can prefer the project B. So in this method or in the previous method, here the discount factor, or that is the time value of the money, is considered. So the present cash inflow is to be converted. The cash inflow is to be converted into the present value by considering discount factor, and the project which gives higher net project value, that is to be accepted. With this, I thank all the students, and the references Shashi and Gupta, G.V. Baligar book you can prefer. Thank you, one and all.